Hello, in this video we're going to be deploying our custom Java server to the cloud. The cloud of choice was Azure in this case, and the main reason for that is because I wanted to integrate PlayFab services in the near future, and that's also with Microsoft, so I figure there might be some advantages with using Azure for this service deployment. I will be using Terraform in order to deploy this. So what is Terraform? This is an infrastructure automation tool. So I'm essentially handling the deployment process through code, which is something I like. And Terraform is an open source library. So if I wanted to, for example, switch my cloud provider from Azure to AWS, I'd still need to make some changes, but it shouldn't be too significant, right? So this should really make it quite flexible in the future if I wish to change. So all of the steps to reproduce what I'm going to be covering in this video should be documented in this blog post, so do check that out. I will be using this doc throughout this video, so you'll probably see me referencing back and forth between it. So I'll be trying to capture all of the steps here, and I'll probably try and edit in the demo into the start of the video as well, so you can see what it is that we're producing as part of this video. I took all of the components down, so we're going to be effectively spawning them from scratch, and yeah, I think that's mainly what we're going to be doing. So let's begin. Okay, so this is the quick demo now of what we'll have accomplished at the end of this video. We'll have spun up all of these pods and these services, and what I'm going to do is I'm going to connect my Unreal Engine game to this service over here using this external IP. So this is a load balancer which will then connect it to the pods. And in terms of Azure, these are the resources that Terraform will spawn, and so I'm going to show the resource groups as well. So I am controlling this resource group, and it will have also spawned this resource group for handling the load balancer. So you'll find the load balancer over here. And let's quickly demo the two clients that I'm spinning up locally. So this is now fully connected with the Azure cloud. So I'm going to go ahead and log into one character in one client and another character on another client, and I'll be able to run around, and you can see it's fully synced up. And so my things like skills and other features should work as expected. So for example, I'll be able to heal myself, and this is replicated against the two clients. I'll be able to cast other skills as well. So there we have the game somewhat working right now. So this is just literally connecting it to the cloud. And yeah, so we can continue on with the video. Okay, so before we go straight into code, let's quickly discuss what it is that I'll be provisioning in Terraform. So as well as my application, it will have some dependencies. So my application will require a DB. So in my case, it's going to be this Mongo database. I'll need Kafka for my event streaming services, and I'll need Redis as my cache as well. So those three are going to be the services that I'll also spawn in Terraform and link them together to my application to make sure that my application is able to access them as well. So those are the services that I will be provisioning, and now we can start looking into all of these resources referenced in Terraform. Okay, so the first file that we'll look at is this main.tf, and tf will stand for Terraform here. And this basically specifies the providers that we're going to be using inside Terraform. So there's two providers. The first one is Azure, because we're deploying on the Azure cloud, and the other one is Kubernetes. So the Kubernetes doesn't need to be modified because it will be evaluated through the kube-config, and this will be generated for us in the next steps that we'll see, but you will need to make some changes to link your Azure here. So you need to link it to your environment, So you're going to need these pieces of information to do that. So it's the subscription ID, and these three pieces of information, the client ID, client secret, and the tenant ID, can be evaluated or created when you create a new IAM user role, essentially, right? So which is going to be used for our API commands. So we'll see that shortly. So in terms of the subscription ID, we can find this on your Azure UI. So you can see it over here, but if you don't see it, simply search for it like this, and you'll get to this page. So what you'll want to do is add a new subscription, and it's pretty straightforward to do that. You just have to define a couple of things. So you can see I don't even need to make any modifications. Sometimes you may want to add some tags here, potentially allocate a budget as well, but simply click create, and you're going to effectively receive this subscription ID, and then all of the services that we're going to be creating will effectively be linked to this subscription. So that's how you get your subscription ID. So next, what we want to do is create the client ID, client secret, and the tenant ID. And in order to create those, we just need to execute this command. So I've got this documented in the README over here. And I'll just reference it over here. And let's just check what it says in the Microsoft documentation. So this basically creates a service principal and configures its access to the Azure resources. So that's what we want to do. And it just requires two changes. So the first one is the service principal name, test service. And the role can stay as an owner. I tried to experiment with contributor role, but I was having issues with my container registry, specifically giving it some access to my AKS, so it wasn't able to create those roles as a contributor. It needed to bump it to an owner. So that's why I've got that as an owner here. And the other thing that I need to modify is this subscription ID. So as we saw earlier, we're able to get that from here. So let's just paste that in, and we can execute it here. And this should go ahead and create this for us. And as you can see, it gives me this app ID, which is the client ID. It gives me the password, which is the client secret, and the tenant ID. So what I'm going to do is I'm just going to delete this now, because I don't need it. Like, this is a huge security issue if I was to just show that here. And I'm able to basically find it under my OpenMMO, under access control. I'm just going to refresh this. The privileged users should go to 4, and I'm going to go ahead and delete the one that I've just created. So this is the one I've just created. So you saw how I got those credentials. So I'm going to go ahead and delete that. But I've already got one created previously, so that's the one that I will be using. Okay, so once you've got all of these credentials at hand, what you want to do is create this terraform.tf vars file. And the way it looks is like this. So you can see terraform.tf vars, and you simply reference all of the credentials here. So Azure subscription ID, client secret, and the tenant ID. So I've crossed them off here for security purposes. And this is not included in Git. So I've added it to git ignore. And this is how we essentially link it to here. So you can see I've defined these as variables. So that's how Terraform will know to look in here and get the values provided, and it will link it back into here. So this effectively concludes the main.tf. So let's see what's next. And as we go down, you can see that I've linked all of the information that we've just gone through about how to get a subscription and how to create this new service principal. So everything that we've just gone through is documented over here. So I guess the next thing that we'll look at is creating the AKS. So let's check that out. Okay, so AKS is the Azure Kubernetes cluster. So this is Kubernetes managed by Azure, and this will sort of help us deploy and scale our applications and services in Azure. And there's a couple of points of interest. So the first one is the VM size. So I've allocated standard B2s here. So if I go over here, this is the standard B2s. And the key thing is this memory. So I basically required to specify a VM with at least 4 gig memory here. So this seems to be a requirement from Azure. Not sure if the other ones have similar limitations. I was surprised it was 4, to be honest, as that seemed relatively large, but that's why I allocated this standard B2s here. And the other thing I'll just point out here as well, so I've commented this out. I was also experimenting with enabling IPv6. There's some additional config that is going to be commented out throughout some other parts of code where I've tried to enable IPv6. It does work, but it also meant that I needed to have a standard load balancer instead of a basic one, and that basically incurred more cost. But you'll be able to see some commented out code in GitHub, and this was for enabling the IPv6, which I'll probably try and experiment with again in the future to see how much of effect it will have on latency and things like that. Okay, so the next thing that we have referenced is this container registry. So this is essentially how we get our application onto the box. So we're going to be creating a Docker image containing our application. So you can see there's this Docker file, and it copies the jar, and it basically provides this entry point to execute our jar. So it builds the Docker image, and it's going to be stored inside this container registry. So the other thing that we also need to do is provide role assignments. So this gives our AKS the privileges to pull this image. And I can just reference this back to this role requirement here. So in order to execute this role assignment, we're going to need the owner privileges here. So this is where the contributor wasn't enough. It was fine for everything else except for this. So if you're going to be using a container registry elsewhere, perhaps you're not going to need the owner privileges here as well. But this is the dependency here. And the client certificate and the kube config, these are outputs. So they're going to be creating these kube configs, and they were referenced over here. So this is the client certificate, for example. That's how they get generated. And perhaps the other thing to mention here is the resource group name and location, which is effectively allocated to the majority of the resources. And the name is pretty standard. It can be anything you want it to be, but the location should be changed to your requirements, right? So in my case, I've set this to UK South, and this basically allocates my resources to this region, which should be closer to me, so therefore I'll expect lower latencies and things like that, right? So you'd want to change this depending on your requirements. Okay, so let's just sync up with the post again. So we've looked into creating the AKS. So we've gone through all of these details, the resource groups, the container registry. So the next thing that we'll look at is adding MongoDB. So we can find the configurations in mongo.tf. So let's have a look at that. Okay, so I mainly just want to reference these mongo.tf, the kafka.tf, and the redis.tf. I'm not planning to go into too much detail for them, mainly because I didn't spend much time configuring them, so I expect there's going to be better ways of defining them as well. The main focus was getting the application up and running, so the basic configurations was sufficient for me. So I wouldn't, for example, trust these configurations for production use, but they might be useful for some people to get up and running, right? So the key thing here perhaps is the service, which effectively will specify the ports for use. And the other thing to note is that my Kubernetes deployment.tf file will reference all of these services and how they're effectively managed on the pod. So for example, when it's spun up, these are the environment variables that are provided to that pod. These are the container port that's exposed. And the other interesting point is that replicas. So for example, if I bring it to 0, this will actually spin it down. And if I set it to 1, is going to have one replica, so one pod running for Mongo. And it can actually handle multiple as well, right? So that's the mongo.tf file. There's more details in the post, so check that out. But again, this is perhaps something that I'll be modifying in the future, so I'm not sure whether this will be the best config to use for production. Okay, so if I go down, this is the Mongo config. So I also referenced it in the Kubernetes deployment. So we'll also have a quick look into the redis and a Zookeeper. So Zookeeper is required for Kafka, and there's also going to be config for Kafka as well. So I'll just go down to the bottom of these, and we can have a quick look into those as well. Okay, so let's open up the Redis config next, perhaps. So this one, very similar to Mongo, you have to specify the persistent volume, the volume claim, and the service that's exposed. So again, specifying the ports here. Zookeeper is required by Kafka. So again, very similar volume, volume claim, and the service that we're going to be exposing. And perhaps the more interesting one is the Kafka. So this one definitely requires some modifications because at the moment I've just enabled it for plain text. So I've disabled Sassel here, which will definitely be required. But in terms of testing an MVP, or rather just like the testing part, I don't need Sassel enabled right now. But it would definitely be one of the things that I'll want to enable in the near future. So for now, I've just disabled it. But I need to provide it some configuration properties to effectively communicate with Zookeeper over Sassel and my application as well. So like I say, at the moment it's just going to be running on plain text. So I've still got the port which would be used for Sassel, but at the moment it's not used as it's got some issues. So all of these services or all of these deployments are handled over here. So you can see that Kubernetes deployment. So here we had Mongo. Here we have Redis. So again, this is specifying the image that's going to be used and the commands as well as the potential environment variables that need to be defined as well. So Zookeeper needs to be configured to Kafka. So it's got some environment variables exposing, for example, the client port here and Kafka as well. So here's the image of Kafka that we're using. You can see I've disabled the Sassel here. So there's going to be more work to be done on these deployments, but this is where I've got all of the configurations referenced. So the ones linked in the blog post, all of that works under the sort of basic configurations. So it could be fine for just doing some light testing, but I wouldn't consider it production grade configurations at this point, right? Okay, so the next item on the list is the application VM config. So we can find this in the app vm.tf, and let's open it up here as well and go through some of the properties that we have configured here. So I want to highlight again, right? Some of these are just for test purposes, so you certainly wouldn't be putting your username and password in plain text like this. Right, so they should be generally part of your environment variables, or perhaps add them to terraform.tf vars. That's going to be fine for your test environment. And let's see what else we have here. So this is going to be an Ubuntu server, and I'm also going to be exposing a public IP. So this public IP is going to be static. I think it should, yeah, there it is. So it's not going to be changing while this service is up and running. And if you have a domain name, you will link it to the IP provided through here. You can actually link domains using Terraform as well. I've not done that. I'm just going to be linking directly to an IP address. And as I mentioned, we're going to be deploying with IPv4. So if I wanted to enable IPv6, I'd also be uncommenting this piece of code as well. So like some of the other ones, it also exposes a service, and part of that I have to give it some additional information. So for example, again, I'm reiterating that it's going to be running on IPv4, and I have to specify some of the ports which are going to be exposed. So my application runs on port 8081, but I will be receiving them on port 80, which should be the default one, right? So anything that I receive on port 80, I'm going to be redirecting to 8081 to my application. Right, and I'll just open up my application.yaml file and just show you that my server runs on port 8081. Okay, I'm also going to be opening up port 9876, so this could be whatever you need it to be. In my case, my UDP server will run on this port, so that's why I'm going to be exposing it here as well. So if you need others as well, you can just expose them as you see fit. So this should be what I need for my application, so obviously you'll have to modify it depending on your needs. Okay, and just like the other services, we also have to reference the Kubernetes deployment. So there's the Kubernetes deployment for my Micronaut VM. So this will be the same for Micronaut or Spring Boot and other similar services as well. So again, I'm able to control the replicas here. So if I bring that down to 0, it will shut down the pod. I can also spin up multiple at once as well. And here I specify the container image that it's going to be pulling. So you can see that it's pulling from this container registry. So this OpenMMO registry has to match the name that was specified over here. So remember, we've got this Azure container registry, and the name here is OpenMMO registry. So if you're changing this, you're going to need to modify the name here as well. And so we'll go through the steps of building, tagging, and pushing these images shortly as well. So we'll see how we tag this release, and it's going to effectively be pulling the latest tag. The other thing to note is the image pull policy is always, which basically means if I was to restart the pod or bring this to 0 and then bring it to 1, is going to effectively pull the latest code if there's one available and use that. So this is quite useful for deploying my code and updating it. Okay, so let's sync up again with the post. So we've just had a look at the VM config. So the next section was networking. Now, to be honest, I don't think I've used this at all. I've just added it here simply because I've still got it in code. But all of my services are part of the same AKS. So they will effectively be networked inside the same Azure Kubernetes cluster. So I'm not going to need these network configurations, I'm pretty sure. But if I was to be communicating with external services which were outside the AKS, then I would need to define this networking, and I would effectively start connecting these services via this network. So I'm not going to go over this because I don't think I need it, but perhaps in the future when I'm going to need to interact with other services, I may need this again. So let's keep going. So now we're looking to deploy the application. Okay, so the first thing that I'm going to do is set replicas from 1 to replicas equals 0. And this will basically create all of the resources for me, but it will not deploy the actual pods. And this is useful because I don't actually have my Docker image with my application built, so it's just going to fail, right? So I'm just going to deploy the resources, and then I can build the image and push that to the container registry. And then once that's ready, I can set the replicas to 1, and it will pull it from the container registry. So that's what we're going to do. Okay, so we'll find all of these replicas equals 1, and then we'll change it to replicas equals 0. So let's go ahead and do that. Once that's done, what we want to do is Terraform apply it. So first, let's change to the right directory. So we're in the OpenMMO one, and type Terraform apply. So now it's going to do some checks. So it's going to do Terraform validate. It will make sure that the config is valid. And then it's going to try and apply it. So this is what it says it's going to do. It's going to add 29 resources. So you can go ahead and check everything that it will add. But we've just gone through it. So what I want to do is click yes. Now this is going to take a couple of minutes to apply. I think it's around 5 to 10 minutes. So I'll just look to do the Docker image now and prepare that for deployment. Okay, so we'll just reference the steps from the blog post again, and if we go down here, there's a couple of setup, but we're going to run through these once the Terraform apply has completed. So this is just configuring Kubernetes locally on our CLI, so preparing the local applications. So I'll go through those shortly as well, but this is really configuring the application to actually connect with the deployed services. Adjusting the local Docker. Okay, we'll go through those as well. And now we can see the steps for building the Docker image for the build. So this is what we're looking at. So what we want to do is build these applications, right? So here we go. Okay, so what we want to do is just execute these commands in our CLI. So what we'll first do is get the path for this folder, and then we'll create a new CLI. So we'll just go to this path, and now we can execute these commands. So yep, this is where we get the name from as well, by the way. So let's go and start executing these builds. Now we can tag the image. And the next step would fail if we haven't been authenticated yet. So what we will probably need to do is just log out and re-authenticate. So that's what I'll just do right now. So first we need to log into Azure. I'll just copy the next command. This is to log into the container registry. So here I'm going to log in there. Now I'm going to be logging into the container registry. Now I'm going to be running this tag command again. Let me just check this. And now I'm going to be pushing that onto the server. Okay, so this will take another minute or so, so I'm going to pause here. Okay, so that's done now. So that's pushed to the container registry, so that will be available. I also just fixed a little typo over here, so that's fixed. And what we'll now do is go through some of the steps that we've seen above as well. So this is really to authenticate our Kubernetes to execute some of these commands locally. So now that this is deployed, let's see what happens if we try and simply get all of these pods. So you can see that we're not able to link to it. This is because my credentials are from the previous iteration and they're not currently valid. So what I'm going to need to do is get the credentials. So you do it through this command. So you can see they exist. I can just overwrite that. So that's fine. And now if I get all pods again, this should work just fine. So there we are. These are all of the pods that have been spawned now. So remember that our replicas have still been set to 0. So what we'll want to now do is change them to 1. And this is because we've now deployed our application to the container registry. So now it's safe for us to deploy the pods. So this is for all of the services like the MongoDB, Kafka, Redis, as well as the application itself. So now with this applied, let's go ahead and do Terraform apply, and we'll click yes when it asks us to confirm these changes. Let's give it a minute. Okay, and this will go ahead and spawn those pods for us. Okay, so let's quickly look into the application config while that's loading. So this is about connecting our application to the other services like Mongo, Redis, Kafka, and the connections that we needed to make to establish that. So let's just open up the application.yaml here. So this is really setting these URLs up, right? So you can see that we've got Kafka broker referenced here. So if we just check with a post, this is because the Kubernetes service has a name of Kafka broker. So while you're inside the Kubernetes cluster, it will handle these DNSs for you. So basically, as long as you call the name, there will be a DNS entry for that pod in order to establish that connection. So this is really useful for us. So that's what we can see here, and let's just confirm that in here as well. So there's the Kafka and Kubernetes server service Kafka, and there's the name Kafka broker. So this has to match to your entry in the application .yaml file. So as well as Kafka, there's also going to be Mongo. So let's have a look. So there's the Mongo service. So if we find mongo.tf, there's the Kubernetes service Mongo, and there's the Mongo service referenced here. And there's going to be another Redis one as well. So you can see it's just pointing here. And if I go to redis.tf, you can see that the Kubernetes service Redis has this name Redis. So that's how we're able to resolve the IPs for all of these services. And that's how the application is able to link to them. Okay, and the other way to identify them is through CLI as well. So if we go back up here, we've got a command to list the services. So this will be a very useful command for us. And when we execute this, so now I know that it's finished deploying them. So if I go here, you can see the names referenced here. So Kafka broker will match Kafka broker here. And we've got the other ones as well. So there's the Mongo service and Redis as well. So all of these have been referenced inside this application.yaml file. Okay, so let's keep going on with the post. So I've just referenced the Kafka, Mongo, and Redis. So we've just looked into all of those. The other thing that I want to look at is adjusting our local build as well, because I want to make sure that it works both locally and on the cloud. And you can see that I basically needed to connect with localhost. So in order to do that, I actually had to make an entry into this hosts file. So let's go inside here and let's see what's inside there. Okay, so inside this directory, we can find this hosts file. So if we go ahead and open that, what I needed to do is add these three entries. So these are the three dependencies that the application required, right? Redis, Mongo service, and Kafka broker. And we just simply point it to localhost. And what that means is that when your application is trying to resolve this IP, it's going to first check inside this file. And if it manages to find the entry, this is the IP that it will use. That's basically what's happening here. So now I'm able to use the same application.yaml config for both my local setup as well as the cloud setup. Okay, and now I think we're at the point where we're able to start integrating this application with our game. So let's have a look again at these commands. So again, this services commands is very useful because we're able to get ourselves this external IP. So this is the external IP that's accessible for me to use to get to our server. So for example, I can just do ping this IP, and you should see that it is in fact reaching it, right? So this is the IP of this server, and now I just need to integrate this with my game. Okay, so in my Unreal Engine, I have the main game instance, which is like the global variable store. So all of my other blueprints that require connection to the server, they'll basically ask here for what URL to use, right? So I basically will call this prepare URLs function on event begin play. I'll make sure that my running local variable is disabled. So you'll be able to see there it is disabled in the screen. And so it's going to go through this false, and I'm going to set the server host to what we've just seen over here. So this external IP, right? So ending with 131, yep. So the other things that I'm going to do is set the port here. So this is actually redundant. So if I'm doing this locally, I need to run on port 8081. When I'm going to be connecting to my server on the cloud, you saw that I'll be receiving the communications on port 80. Then I need to also set up the WebSocket path as well. So that's what you can see here. So yeah, we're basically ready to try this out now. Okay, let's go ahead and click play. Before I do that, let's just check. We've got the net mode on play standalone and number of players 2. So, okay, cool. Maybe you just saw that, but it gave me the connection established message, which is great to see. Then I can go ahead and create one character here. And so you can see it's actually communicating with the server again. So these requests are over HTTP. And for the second character, maybe we'll just make him look different. So let's just do that. And we can go ahead and log into the world. Okay, so that's with one character and that's the other. All right, cool. So now we should be able to see each other running around. So that's looking pretty good. Okay, so this is actually sending all of the requests to my server, and we can check this with the logs. So let's open those up as well. So in order to see the logs, what we want to do is get all the pods, because we'll need the pod name, and we are going to be executing this command. So let's just put that in. Then copy the pod name. Okay, cool. So let's just have a look at this as well. So I've still got the game up here. So we should be able to see changes as we're running around. And bear in mind, by the way, that at the moment I'm logging all of the requests that I'm receiving through UDP, and that's actually quite slow. So what I'm going to demonstrate now as well is let's see how we can remove those logs. Push this to see whether the game will be even smoother than what it is right now, right? Because I actually do see a small delay there. Perhaps it can get a little bit better. Let's check that out. Okay, so there's two logs in particular that I'll want to remove. So the first one is going to be on this send, and the second one is going to be on a message received. So these will be quite noisy, and depending on your disk, so I think I'm using a really basic disk here, is going to slow this down quite considerably because I'm going to be spamming these messages. So what I'm going to do now is I'll click assemble. And again, I'm going to be receiving this jar file. I'll copy it over here and I'll run through the docker build commands. And then I'll push this onto the container registry. And yeah, we'll try this again. Okay, so that's finished deploying now, or rather that's finished uploading the image to the container registry. What I want to do now is get pods. So here is my pod over here, and I want to do delete pod. And what this will actually do is it will ultimately restart it. So it's managed by Kubernetes. So in terms of the replication factor, it's got 1, which means that if you delete it, it's going to try and restart it. So if I bring that up again, so there you can see it's now up and running again. It doesn't take very long for me to start these. So if I do kubectl logs, this is primarily why I like Micronaut. Is it's got very fast speed to start up, so it's really good for that. So it's actually up and ready for me to test again. One thing I will just show again is that if I was to get the services, you'll see that it's going to be exactly the same IP, and that's because my pod is we're not connecting directly to the pod, right? We're connecting to a load balancer, which then points to the pod. So this IP is static. So let's follow the logs again, and we can start the app again. Okay, so let's go ahead and click play here. So the characters still exist as expected. So we'll just log into these two characters. And so I'm not sure whether it's smoother, but it's looking pretty good to me anyway. And what we can do, I guess, is we can also add some skills. So we can see that I've still got the skill replication working as expected. So perhaps we can just throw some heals onto these characters, maybe throw some fireballs as well. So things are looking pretty good now. And let's just open up the logs. So in terms of the logs, they're looking a lot less noisy now. So you can see I'm just getting occasional updates for the motion repository, which syncs up every now and then with the repository. The actual information is generally pushed to the cache layer, and then occasionally will sync up with the repository as well. So looking a lot less noisy now. So yeah, that's it for this video. We've covered quite a lot. We've basically went and deployed our services to the cloud now and integrated our game with them. So starting to look a bit better. So thanks and see you next time. Bye.